Hi folks, we're going to take a look at number 8 from page 263. So what they're asking us to do here is to find the equation of the tangent to this curve that's also parallel to the given line. Okay, so first thing to keep in mind is that this line is not the tangent line. Okay, what we know is that this the tangent we're looking for is parallel to this line. Okay, so what that's going to help us figure out is the slope, because if we're looking for the equation of the tangent, we need two things. We need the slope of the line and we need a point on the line. So this will help us determine the slope. So we'll just solve for y. So we get y is equal to 3x minus 9, and of course that gives us a slope since it's parallel. So we know that our slope is 3. What we need now is a point on this line. Now, since it's tangent to this curve, we know that the that the tangent and the curve share a point, okay, where it's tangent. So what I need to do is figure out where this curve has a slope of exactly 3, or a derivative of 3. So the next step is to find the derivative. So derivative here is, well, derivative of x is just 1 minus. Now here I have to use the chain rule because I don't have e to the x, I have e to the minus x. So my u here is like my negative x. So derivative of e to the u is just e to the u, so e to the negative x, okay? And then times the derivative of negative x, which is just negative 1. Okay, so my derivative is just equal to 1 plus e to the negative x. Here I simplify because I actually need to do something with it. I need to figure out when this derivative is equal to 3. Okay, and now I have a fairly easy equation to solve, so bring the 1 to the other side. So I have e to the negative x equals 2. Again, easy to solve, just take the natural logarithm of both sides. So I've got ln 2 equals negative x. Since the natural log of the natural exponential function, those two are inverses of each other, they cancel each other out. So I've just got that x is equal to negative ln 2. Okay, so here's the x value of the point that they share, and in order to find the y value of the point that they share, I just have to stick back in to the equation of the curve. Okay, so the y value will just be given by x, so negative ln 2 minus e to the negative ln 2. Okay, and again, I'd like this as simple as possible since I actually have to work with it. So here, negative ln 2 minus, and here, negatives just cancel out, so I'm just left with e to the ln 2. And again, these two are inverses of each other, so they just cancel each other out. So negative ln 2 minus 2. Okay, now that I have a point, so the x and y value, and the slope of the line, I can find the equation. Now this is one of these examples which is really nice to use the point-slope form instead of the slope-intercept form, because here these are not particularly nice numbers and solving for b would be a bit annoying. But if I just use point-slope form, which is y minus the y value that I'm given, so negative ln 2 minus 2 equals the slope 3 times x minus the x value that I'm given, negative ln 2. And we'll just simplify this a little here, so distribute the negative 1, so y plus ln 2 plus 2 equals 3 times x plus ln 2. Okay, and there's point-slope form. And if I actually did want it in slope-intercept form, I could just distribute, bring that to the other side, and write it in the y equals mx plus b form. But that's not necessary here. Okay, so just to recap, here, very similar to many problems we solved in the past, we just happen to have an exponential function here. So because it's parallel to this line, we're able to determine the slope, and from that we can use the equation of the derivative to figure out at what x value it has that exact slope of 3, and then from there plug it into the function to figure out the y value.